All right, let's just get this out of the way. Everybody, and I mean everybody, is still hammering on the front door of the web app, chasing that same old XSS and the same search bar they've been poking out for a decade. Sure, you might find a little something, but the real score, the stuff that gets you paid, the stuff that gets you a reputation, that's not at the front door. See, the pros, the operators, we know there's a back tunnel, a private entrance that goes straight to the server's brain, and that tunnel is the mobile API. So while everyone else is making a ton of noise out front, we're going to slip in the back, nice and quiet. That's the whole idea. Forget the web app, we're going straight for the API. This right here is everything. Your average bug hunter, well, they're like a tourist. They fire up their proxy, they click the buttons the UI gives them, and they stay right inside that little playground the developers built. A master? A true operator? We don't play in the playground. We look at the client and all we see is a list of assumptions, a list of hopes and dreams the developer had. Things like, oh, the server will definitely validate that, or nobody would ever think to just add an admin field to the JSON. The biggest, ugliest, most career-ending bugs, they all live in that gap between what the developer assumed and what the server actually does. Our job is to find that gap and just drive a truck right through it. So where is this real attack surface I'm talking about? Well, it's not in the JavaScript you can just view source. Nope. It's buried in the compiled code of the company's mobile app. Just think about it for a second. The mobile teams, they move at 1,000 miles an hour. They're shipping features constantly. And they build all these private, versioned APIs. The API/mobile/v3 or Edge/v1 kind of stuff that the public website never even knows exists. These endpoints are built on caffeine and deadlines, they change every other week, and they are an absolute goldmine of logic flaws. The devs, they figure, hey, it's not on the website, nobody's looking. They're so wrong. The mobile app, it's their private diary, and we're about to read it cover to cover. Okay, let's be crystal clear about something. Dropping an APK into JADX or some other decompiler, that's not the hack. Finding a hard-coded key and running to cache it in, that's what amateurs do. For us, decompiling the app is intelligence gathering. It's espionage. You're not a hacker at this stage. You're a spy. You're building a complete dossier on their backend. What's their design philosophy? What third-party libraries are they using? What half-finished features did they try to hide behind a feature flag? The static analysis? That isn't the final blow. It's you drawing the blueprints to their entire operation. Because remember, the bug isn't in the app. The bug is always on the server. All right, so phase 1. We're going to read the client's mind. This is all static analysis. We are putting the application on the operating table, and we're going to dissect it piece by piece without it ever running. This part isn't about being fast. It's about being meticulous. You're like an archaeologist here, slowly uncovering a forgotten city. Every little string, every class name, it's all a clue. We're building our entire case before we even send a single packet. So what am I hunting for when I pop one of these open? First, base URLs. I'm grepping for everything, not just your standard domains, but those weird versioned API paths. That's where the good stuff lives. Feature flags? Oh yeah, that's basically the developer's to-do list of broken, insecure features they haven't finished yet. GraphQL queries are a gift. They literally hand you the menu for the entire backend. gRPC services, SDK keys, deep link patterns. And my personal favorite, developer comments. You find a little double slash, to do, need to fix this security issue before launch? Well, that's just the server sending you a thank you note in advance. And this is the critical step. This is where we turn that raw intel into actual testable ideas. A clue by itself is not a bug. A clue is just the beginning of a question. So you see an Xorg ID header in the code. The question isn't, is this a bug? The question is, I wonder if the server is lazy enough to trust this header over the cryptographically signed JWT. You find a hidden role field in a data model. The question becomes, I wonder if the server will just let me promote myself. Every single piece of intel we find is just a hypothesis about how the server side might be vulnerable. Okay, enough planning. We've got our clues, we've got our hypotheses. Now it's time to actually see what's happening on the wire. This is dynamic analysis. We're setting up our proxy, running the app, and just watching. We're observing the real-time conversation between the mobile client and the server. We're not attacking yet. This is still reconnaissance. We're confirming that our intel was right and seeing how this thing actually behaves in the wild. And you really need to pay attention here, because if you miss this, you're going to miss the big bugs. The session lifecycle is the heart of the application. You have to map the whole thing. How does login work? How are tokens created? How are they refreshed? And most importantly, how does logout work? You have to ask the tough questions. When I get a new refresh token, does the old one actually die? Or is there a zombie token still floating around that's valid? When I hit logout, does the server really kill my session, or does it just kind of forget about it? You would be shocked how many huge applications are built on nothing more than a digital pinky swear. This is where things get really interesting. To the user, they see one button. It says Update Profile. They tap it. In their mind, one thing happened. But in our proxy, we see a whole cascade of events. First, there's the post to the profile update endpoint. But then, a half second later, there's a silent call to a completely different server to sync entitlements. And then, another call fires off to an analytics endpoint. So one tap from the user triggers 3 different API calls, touching 3 different backends, probably written by 3 different teams. That's 3 different opportunities for a screw-up. Our job is to analyze the entire sequence, not just the obvious first request. So, what are the best places to hunt? You gotta look for the weird flows that only exist on the mobile app, the stuff the web developers never even think about. Device registration and Bootstrap, it's always a complete mess of misplaced trust. Organization or tenant switching, that's a minefield of session handling bugs waiting to happen. And my all-time favorite, file uploads from the camera. You're not just hitting a web server anymore, you're hitting this whole back-end pipeline of strange, probably unpatched third-party image processing libraries. It's a surprisingly direct path to remote code execution if you know what you're looking for. And now, it's showtime. We've got our intelligence, we've mapped the terrain, it's time to act. But let me be perfectly clear. This is not the part where you fire up a fuzzer, crank up the threads, and go get a cup of coffee. That's for clowns. We are operators. We move with absolute precision. We send one packet to ask one very specific question. We test one hypothesis at a time. We are scalpels, not sledgehammers. We're quiet, we're clean, and we're professional. So here's a classic scenario, something I see constantly. Our static analysis told us the app uses an Xorg ID header. Our dynamic analysis shows us there's also an organization ID claim inside the JWT. So the client is saying the same thing in 2 different places. Why? Well, that's a red flag. Redundancy in security often points to a flaw. It means 2 different developers probably solve the same problem in 2 different ways. And whenever you have 2 sources of truth, there's a very good chance one of them is a lie. Our hypothesis is simple. The server is listening to the wrong one. So here's how we test it. It's beautiful in its simplicity. Request A is our control. We send a valid token for tenant 123, and we send a header that also says 123. We get a 200 OK back. Great. Everything's working as expected. Now for the experiment. Request B. We use the exact same valid token for tenant 123. We don't change a single byte of it. The only thing we change is that one simple plain text header. We just flip it to say we want tenant 456. We send it. Now, if the server's built correctly, it should laugh at us and send back a 403 forbidden. But if the response comes back 200 OK, and inside that response is the data for tenant 456, congratulations, you just won. That's a critical IDOR. Game over. All right, let's talk about a developer's favorite shortcut, which also happens to be one of our favorite vulnerabilities, mass assignment. This is what happens when developers get a little lazy. The server gets a big JSON object from the client, and instead of carefully picking out the fields it expects, like, email or first_name, it just takes the entire blob and maps it directly to the database model. The server is just blindly trusting that the client is only sending the fields that are visible in the user interface. But of course, we're not using their user interface, are we? We've already read the source code. We know about all the fields they didn't want us to see. So the attack itself is almost embarrassingly simple. You capture a normal request, like a profile update. You see the normal fields, email, and maybe plan. But then you remember from your static analysis that the user object on the server also has a Boolean property called is_admin. The mobile app never sends it, but the database has a spot for it. So what do? You just add it. You slip is_admin true right into the JSON, send it off, and see what happens. And if you suddenly find you have God mode on the application, well, you just found a critical privilege escalation. And trust me, this works way, way more often than you think. Look, finding a single bug, that gets you a thank you and maybe a small payout. Chaining multiple bugs together, that's how you become a legend. This is the real difference between a bug hunter and a true operator. Amateurs find a small crack in the wall. Professionals take that small crack, turn it into a massive hole, and then walk right through it. We don't just find individual flaws, we weave them together into a complete story of total compromise. This is what separates the 4-figure bounties from the 6-figure ones. So here's how a real chain works, step by step. First, the intel. We're digging through the decompiled app, and we find a weird, internal-looking endpoint, post/fetch/URL equals U. The hypothesis? Classic server-side request forgery. So we validate. We point the URL parameter at the internal AWS metadata service, and boom, it spits back cloud metadata. Now exploitation. We use that SSRF to pivot inside their cloud and steal IAM keys from the machine. And finally, the impact. Those keys give us access to a misconfigured S3 bucket, and inside that bucket, the personal information for every single user on the platform. We just went from one forgotten line of code in a mobile app to a company-ending data breach. That is the job. Okay, let's talk about something a little more advanced for when you're up against a tough target with a web application firewall or load balancer in the way. It's called an HTTP desync attack, or request smuggling. The best way to think about it is like this. Imagine there's a security guard at the front gate and a manager in the back office. You give the guard a package that looks like one single item, but you've cleverly hidden a second item inside it. The guard looks at it, says, "Looks fine," and passes it along. But when the manager in the back opens it, that second hidden item falls out, and he processes it, thinking it's a brand new, legitimate request that the guard already approved. That's exactly what we're doing, but with HTTP requests. The trick is to craft a deliberately malformed request that confuses the servers. We use two different headers, content length and transfer encoding, to describe how big our request is. The front-end proxy will look at one of those headers, but the back-end server will look at the other one. Because they disagree on the size, the back-end server thinks our request finished early, and all the leftover data? Well, that's our second smuggled request. The front-end proxy never even saw our get/admin request, but the back-end server sees it as a fresh, new request and happily executes it. It's a really beautiful, elegant way to bypass entire layers of security. So we've gone through a lot of tactics, but here's the thing. Tactics change. Tools get outdated. The only thing that really lasts, the only thing that separates the pros from the crowd over the long term, is the mindset. It's about having a disciplined, repeatable, professional methodology that you can apply to any target, anytime. It's not about what tool you run, it's about how you think.
And why? Why do we go through all this trouble? Why bother with the deep analysis, the careful methodology? That's why. $75,000 for a single bug chain. And that's not a fantasy number from some blog post. That's the kind of money a company will happily write a check for when you don't just show them a small leak, you show them the architectural flaw that's about to flood their entire business. You stop being just a bug hunter and you become a high-end security consultant identifying catastrophic business risk, and you get paid based on that value.
And now we have to talk about the part where most brilliant hackers completely fail, the report. Listen to me very carefully. Your report is the product. You could be the best hacker on the planet, but if the triage engineer on the other end can't reproduce your bug in under a minute, you're getting nothing. I need a one-sentence summary that gets straight to the point. I need a single curl command that's so simple anyone could copy and paste it. I want you to describe the business impact, not the technical details. And then tell them exactly how to fix it. Make it so easy for them to pay you that it would be more work for them not to. That's how you build a reputation.
Finally, let's go over the cardinal sins. These are the traps that will waste your time and make you look like a rookie. Number 1, the bug is on the server. Always. Stop getting distracted by the client-side code. Number 2, a disabled button in the user interface is not a security control. Ever. Number 3, stop wasting days trying to bypass certificate pinning on a production application. Find a debug build or find a different way. The real bugs are in the API's logic. And number 4, data sitting in local storage is not a vulnerability unless you can prove that the server later trusts that data without revalidating it. You have to focus on the server. That's where the treasure is buried.
And that's really the whole game. It never stops. Right now, as you're listening to this, your target is probably pushing a brand new build to the App Store. It's a whole new map full of new secrets and new mistakes. So what are you going to do? Are you going to go rattle the front door along with everybody else? Or are you going to pop the hood, read the developer's diary, and find that critical flaw they don't even know they just shipped? The opportunity is right there. The secrets are in the code. Go get them.